So in our previous video, we had a whole bunch of endothelial cells and we had a little damage. We had a little damage over here. Exposed some collagen. Our platelets were flying around in our bloodstream and they found the collagen and they made this plug. And I told you before that they put fibrinogen in here. But fibrinogen and this platelet plug, it's only a temporary fix. So what we really want to do is we want to harden this complex over here so that it makes something a little bit more permanent. So in order to do that, we need to change fibrinogen to this other compound called fibrin. And fibrin is a little bit better of a glue than fibrinogen and platelets. So that's our goal. I'm going to just say that this is our goal. But how do we get there? We get there because of damage. When there's tissue damage in this area, there are many chemical mediators that call in different types of proteins that are dissolved in our blood. So I'm going to just draw a whole bunch of proteins. They're going to be in the blood, and at one point they're going to realize that, hey, there's a clot here, and they're going to come along and then help you make fibrinogen into fibrin. So most of this cascade is caused by tissue damage. So tissue damage is going to cause a certain protein, and this is how this whole entire Clotting Cascade looks like. I'm just going to draw off the side on how it looks like. You typically have an enzyme such as 12A. It's a serine proteases. These are all serine proteases. Okay, so let me just start with tissue damage activates proteins called serine proteases. And these serine proteases, they get cut down and they become active. And this active one will take another inactive one and then it will make that one active. And this whole entire process ends up with our goal of changing fibrinogen into fibrin. So we need to know what these factors are. It's really hard to draw a pathway that looks like this. It takes a really long time, and you only have about a minute and a half to answer each question. So what we need to do is we need to do something that will speed things up. I'm going to show you this little chart that I drew for myself whenever I need to solve clotting questions, and it looks something like this: 12, 11, 9, 10, 2, 1. It kind of goes in order, except 9 and 10 are screwed up. And let me tell you what 2 is. 2 is actually thrombin. And before it was activated, it was prothrombin, and then the last one is going to be fibrin. And before that, it's going to be fibrinogen. So they're just precursors, and I'm just going to draw them in order. You just have to make the assumption that the precursor of 12 becomes 12 active, and then 12 active will make 11 zymogen form into 11 active, and 11 is going to go to 9. You get the idea. So that's our goal. So what activates 12? Well, tissue damage. It turns out that there are two ways in which this pathway can be activated. There's actually a way that comes in from factor 10, and that's factor 7. This is also caused by tissue damage. But more specifically, you need to know that when you do have tissue damage, I want to just go up a little bit so you have an idea. There are these little molecules called tissue factor. And then tissue factor will activate factor 7. And then factor 7 will activate factor 10. And factor 10 will activate factor 2. Factor 2 will activate factor 1. That's the idea. So there's two ways in which tissue damage can activate fibrin. So let's remember what I said on my first slide, on my first lecture, and my first video was about how platelets help this process. And I need to tell you how it helps this process. So I need to add in the fact that 9 and 10 requires other subunits. And those subunits are going to be 8 and factor 5. So this is what you need to draw. I'm going to draw it really quick. It's pretty fast. 12, 11, 9, 10, 2, 1, 3, 7, 8, 5. I think of it like 9 minus 1, 10 divided by 2, 3 plus 7 is 10. Whatever works for you, but you have to remember these numbers in some sort of shape or form. 9 and 8 they kind of go together, so I kind of square them off. 10 and 5 come together, so I square them off. So 8 is more of like a subunit of 9. They have to come together in order for 9 to convert 10 to an active form. And then 10 and 5 need to be together in order to activate factor 2. So what you need to do is you need to draw that. The next thing you want to do is circle, or I'm going to highlight those 3 factors. No, let's not do that now. So try to draw this first without help at all. And then let's go to the next step where we actually talk about the regulation.